Welcome to our lesson on parallel and perpendicular vectors. Let's begin by reviewing our formula to calculate the angle between two vectors. We know that the cosine of the angle between the two vectors is equal to the dot product of the two vectors divided by the product of the magnitude of the two vectors. If we were to rearrange that to make the dot product the subject, then we would have the dot product of the two vectors is equal to the product of the two magnitudes of the vectors times the cosine of the angle in between them. Let's consider if these two vectors are parallel. If the two vectors are parallel, then that would mean that the angle between them would be 0 because they are going in the same direction. So if the angle theta is 0, then the cosine of 0 is 1. Or in other words, this cosine theta expression here is no longer necessary to be written. It would simply be that the dot product is equal to the product of the two magnitudes. So let's look at an example. Let's say we're given that the vector A is 3i plus 4j and the vector B is 15i plus 20j. We are to verify that those two vectors are indeed parallel. So let's find the cross product. 3 times 15 plus 4 times 20, that is 45 plus 80, which gives us 125. And then the product of the magnitudes. So using Pythagoras' theorem, 3 squared plus 4 squared, 15 squared plus 20 squared, this will be the square root of 25, that's the square root of 625. The square root of 25 is 5, the square root of 625 is 25. 5 times 25 gives us 125. Since we found the dot product and we found the product of the magnitudes and they worked out to be the same exact value, then that verifies that these two vectors are indeed parallel. Keep in mind that it works both ways. If you find the cross product and you find the product of the magnitudes and they work out to the same number, then that means that they are parallel, and vice versa. If they are parallel, then the dot product will be equal to the product of the magnitudes. Next, what about if these two vectors are perpendicular? Well, if they are perpendicular, then that means that the angle theta is 90 degrees. And so if the angle is 90 degrees, then the cosine of 90 degrees is 0. If we look at our formula here and substitute the value of 0 for the cosine of theta, then everything on the right hand side will be equal to 0. No matter what the magnitudes of the two vectors are, if you multiply them times 0, it will be equal to 0. Hence our result, the dot product is equal to 0. And again, that works both ways. If the dot product is equal to 0, that means they are perpendicular vectors. And vice versa. Let's say you know they are perpendicular vectors, then that means the dot product must be equal to 0. So let's look at an example. Let's say we're to find the value or values of x if the vectors a, which is equal to xi plus 2j, and the vector b, which is equal to xi minus 32j, are perpendicular. So let's say we know that they are perpendicular. Given that they are perpendicular, their dot product must be equal to 0. So x times x plus 2 times negative 32 must be equal to 0. X times x is x squared. 2 times negative 32 is negative 64. Transposing, I'll add the 0 and the 64. So I have x squared is equal to 64. To find x, I square root the 64. And that will give me both positive and negative 8. So my two vectors could be ai plus 2j and ai minus 32j, or negative ai plus 2j and negative ai minus 32j. Remember that whenever you find the square root, it is both the positive and negative square root. So with that, we come to the end of this lesson. See you in class.